In this one, we want to count the number of bit strings of length 5 that contain the bit string 1, 1. All right, so one way to go about this is to first think, okay, let's write out or 5 positions here. So 1, 2, 3, 4, 5. Now the 1, 1 could go there, or we could have something like this. 1, 2, 3, 4, 5. The 1, 1 could go there. Or 1, 2, 3, 4, 5. Let's see, the 1, 1 could go there. Or 1, 2, 3, 4, 5. The 1, 1 could go there. And now, since there's no stipulations on what the other positions can have in them, right, we have two choices, two choices, two choices, two choices. I'm writing CH for choices to abbreviate that. Two choices, 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 two choices. All right, so in each case, right, so if we're actually going to count all these, right, this first one, this would be, you have 2 times 2 times 2, or 2 cubed. There's 2 cubed possibilities there. Same thing here, right, because the 1, 1 in the middle doesn't change anything. So you have 2 cubed here, 2 cubed here, and 2 cubed here. Right, so the overall answer is going to be 4 times 2 cubed. Let's see, 2 cubed is 8. 8 times 4 is 32. So that's one way to look at it. And that's certainly a perfectly fine way of doing it. Let me show you another way. Another more sophisticated way that we'll use soon in the next example. So the way to think of this is you have 1, 2, 3, 4, 5. So you have a bit string of length 5. Now, think about how this goes. So we could occupy these two, and or we could occupy these two, or we could occupy these two, or we could occupy these two. And so notice that this occupy idea, it only matters where the second one, meaning that one, goes. Right? Because if the second one goes there, then that means the other one goes there, right? If the second one goes there, then that means the first one goes there. If the second one goes there, then that means the first one went there. If the second one goes there, then that means the first one went there. So it's basically like we have 4 positions for the second one to go in. Choose one of them, right? So that's the idea. So we have, where to put the second one in 1, 1. Well, we have 4 choices. 4 choices, right? 1, 2, 3, 4, 5. We could either go there, 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 or there. So 4 choices. Choose one. Okay, now once we choose one of those places, it doesn't matter which one we pick. So looking at a length 5 string, 1, 2, 3, 4, 5. Let's say we pick our second one to go here. If our second one goes there, then our first one has to go right before it. And then we have 3 positions. Each one of these positions has 2 choices. 2 choices, 2 choices, 2 choices. And it doesn't matter, just to hit home the point, let's see, 1, 2, 3, 4, 5. If I chose, say, this is the position of my second one, then that means my first one goes there, right? And it's still the same problem. It's 2 choices, 2 choices, 2 choices. Right, so this C41 right here, that takes care of all the different possibilities of where we could put the second one. And then now the problem reduces to, we have how many bit strings of length 3 are there? Right, so 1, that, and now 2, how many bit strings length 3? Well, we know that. That's 2 times 2 times 2, otherwise known as 2 to the third. So the answer is C41 times 2 to the third. C41 is 4. This is 4 times 2 to the third. 2 to the third we know is 8, so it's 32. You can see you get the same answer either way.